video, we're going to start solving systems of equations, and I'm going to show you how to solve them graphically. So the first question is what is a system of equations? And basically, it's more than one equation. Not a surprise there. So we're going to be dealing with more than one equation at a time. We're going to learn how to solve a system. Solution to a system equation. So when we have more than one equation, we have more than one variable that we're solving for. That variable can be x and y, a and b, whatever those variables are, but there's going to be more than one variable. So our solution is not just going to be like x equals 5 or something. Our solution is going to have points, coordinates, where each value represents one of the variables. We will only deal with two variable equations, but as you move up in mathematics, those you'll be dealing with 3, 4, 5 different equations at a time. There are three types of systems with three based on their solution set. One is called an independent, consistent system, and that's when there is one solution. Let me erase this up here. So you have an independent, consistent system. Then we have a dependent, consistent system. That's when there are infinitely many solutions. And the last one we have is an inconsistent system, and that's when there is no solution. Okay, so the first method we're going to learn is how to solve a system of equations graphically. So the steps to doing so is 1, graph each equation, and 2, we're going to analyze. So what are we looking for? We're either looking for an intersection point that would tell us that there is one solution, or that our system is independent and consistent. We're looking to see if the lines are parallel or do not cross. That would mean there is no solution. So the system is inconsistent. Or we're looking for, do we have the same exact line? This would mean that the system is dependent consistent, or that there are infinitely many solutions. All right, so we'll do them by hand, and then I'll show you how to use your graphing calculator to do it for you. So we have, let's graph both of these equations. Our first one is x minus y equals. First, I'm going to go ahead and turn this into, well, actually, I'll show you both ways. This one is already in standard form, so I can find 2 points very quickly and easily. Basically, I'm going to find the y-intercept and the x-intercept. So a y-intercept is when the x coordinate is 0. So if x is 0, that will give me negative y equals 4, which means y equals negative 4. So that's 1 point, 0, negative 4. And my second point, I'm going to assume that y is 0, so that will mean x equals 4. So there's a line to represent that one. And then let's go ahead and graph y equals negative 2x plus 2. This is in y equals mx plus b slope-intercept form. So I know that my b is 2 and my slope is, negative 2. So I'll start at 2, go down 2 over 1, down 2 over 1. There's that line. My lines intersect at the point 2, negative 2, so this would be my solution. All right, here's another example. Y minus 13 equals 5x, and y equals 5 times x plus 3 minus 3. So let's go ahead and graph the first one. Y minus 13 equals 5x. I'm going to add 13 to both sides. This is going to be difficult for me to graph because mine don't go up to 13. I'm just gonna, let's go by 5s. we'll keep those going by ones. Okay, so my y-intercept is 13. My slope is 5 over 1. So up 5, 13, that's the 18 over 1. So that's like here. Okay, and I get something like that. Okay, now let's work on the second one. First, I'm going to get this into a form that I like. So I'm going to go ahead and distribute. I get 5x plus 12 is y. So that means I'm going to start at 12. And my slope is still 5 over 1. So these two lines are going to be exactly parallel. So they're not going to cross. That means no solution. Now, I knew this was going to be a no solution before I even worked it out, because these lines have the same slope. And when they have the same slope, a line is parallel. All right, last example, y equals 2x plus 1 and 2y equals 4x plus 2. So let's go ahead and graph the first one. My y-intercept is 1 and my slope is 2 over 1. So b is 1, slope is 2, so up 2 over 1, up 2 over 1. That's that line. Oh, that's horrible. Sorry, guys. And my second one, 2y equals 4x plus 2. But I want this in slope-intercept form, so I'm going to divide everything by 2. That gives me y equals 2x plus 1. So what do I notice? I get the exact same line. So this is an example of infinitely many solution. All right, that's how you solve a system graphically.